So welcome to the course Design of Machine Elements 1 of VTU 5th semester course. So myself Dr. Raviraj, I am the faculty in the Department of Mechanical Engineering, Government Engineering College, Chamarajanagar. So in this model, in this session we will look at the model number 5, where we will be learning to design the power screws. So before we start the actual content of the power screws, let us see what are the learning objectives of this particular subject or particular topic, power screws. So in power screws designing, first thing, the student will be able to learn or to understand the various steps involved in the design of power screws. So all of you know that design is the process or the steps involved, different steps are involved for particular design of particular element. So here you will understand the procedure or the steps involved in the design of power screws. And once you understand the various steps, you should be able to, you can learn how to explain the principles, or you can understand the principles involved in the design of power screws. And all the machine elements and particularly power screws are subjected to various kinds of forces, and you have to design this particular power screw with respect to strength, rigidity, functioning and manufacturing requirements. And also one more objective is that to understand and interpret the failure modes or the theory of failures to this particular designing of the power screws. And also you should be able to, you can learn one more objective of this particular learning objective for power screws is that you can use national and international standards and different standard data available for designing the power screws. And also you should be able to develop the capability to design the power screws for various applications. So these are the objectives to learn the topic power screws in design of machine elements 1. And the objectives at the end of the learning, you should be able to, or what are the outcomes expected from the student is that the student should be able to apply the concepts of selecting the materials for power screws, and the student should be able to list the functions and the use of power screws in various mechanical systems, and he should be able to apply codes and standards which are used in design of power screws. And also the student should be able to analyze the performance and the failure modes of the power screws, and you should be able to apply the engineering design tools to the design of the power screws. So these are the outcomes what we can expect from the students when they learn the topic power screws with these objectives. So during this session we will look at all these learning objectives, and once the particular topic is finished, then the student should be show or exhibit these particular outcomes from this topic power screws. So before we start the concept or understanding power screws, in the previous sessions or in the previous concepts, you have learnt about the fasteners. So fasteners are basically they are based on the phenomena of threads, on the design of threads. So we have learnt about the threads or threaded profile, and these particularly threads are used in elements, mechanical elements, and they are called as fasteners. So this phenomena of threads are applied for fastening the different components or different elements to each other. So they are called as threaded fasteners. So for example, here you can see different fasteners used. Particularly we simply call them as screws, or we call them as nuts and bolts. So we have nuts, bolts here, and different kinds of screws are there. So on these elements we can see the helical profile, which we call them as the threads. So these are the threads. So all these threads or fasteners you learnt in the previous sessions as per your syllabus. So now we'll concentrate on the power screws. So why you're comparing power screws with threaded fasteners is that power screws are also based on, the function or the applicability of power screws is particularly based on the threads or the threaded profiles. So here the way these power screws are applied is different from the fasteners or the threaded fasteners. So fasteners, as you know, as the name indicates, they are used to clamp together different components. For example, screws and nuts and bolts are used to join together temporarily different components, machine elements or different mechanical components. But when you come to power screws, so power screws also, they are also the thread elements, or I can say elements which have threads. And as the name indicates, power, these elements or the threaded elements, they are used to transmit the power or motion in the mechanical system. So here you can see one example, all of you know, is the screw jack. So the automobile screw jack is one example, a best example for power screws. Similarly, we have the bench wise or the machine wise, where the screw or the threaded pattern is used in the element to the movement of these particular clamps. Similarly, you might have seen in the lathe, you might have worked on lathe, and we have the lead screw which rotates, and the carriage will be moving linearly on when the screw rotates here. So these are nothing but, these elements are basically threaded elements, and which are used to transmit power or motion in the mechanical systems, and that's why they are called as power screws. So screw is a word which relates to the threads, and the word power relates to transmission of, or transmitting the power or the force applied in the mechanical system through this element called as power screws. So this is the basic difference between threaded fasteners and the power screws. So threaded fasteners, about designing these threaded fasteners, you have studied in the previous sessions as per your syllabus. So now in this session we will look at the design concepts or the criteria for designing the power screws and the applications of these power screws. So basically, threaded fasteners, as the name indicates, they are used to fasten or to clamp together two different components temporarily. For example, screws are used, nuts and bolts are used to clamp maybe two sheets of metal or whatever it is together, or different elements together, or different mechanical components which can be temporarily fitted using these nuts and bolts or screws. So coming to power screws, as the name indicates, power and screw. So it's a power screw, nothing but they are also threaded elements which transmit the power. So the best examples or best applications of these power screws are screw jack, this bench wise or machine wise, you have lathe machine or the fly press, something like that. So we'll see this in detail now. So power screws, as we saw just now, they are particularly threaded elements, but basically they are not used for fastening purposes. So for fastening we have the threaded fasteners, nuts, bolts, screws, something like that. So these power screws are basically, I told you, they are used to transmit or transform the motion or the power or the force applied. So how this is transmitting the motion or power, we will see now in the next few minutes. And also using these screws, particularly helical pattern or helical criteria, helical pattern is used to transmit or to convert the rotary motion into linear motion. So you might have seen in automobile screw jacks, when you apply the load in the rotary motion, the screw will move in the linear direction. So that's what is the one of the function of the power screws. So it can convert the rotary motion or the torque into linear motion. And again, during this course of functioning, torque is converted into force. That is, whatever torque you are applying, the rotary motion is converted into linear motion or the force. And one more name what you can use for power screws is translational or translation screws, because they are translating the motions or the power. So they are called as translation screws. And coming to the common applications or the day-to-day life or engineering applications of these power screws, as I told you, the best example is the screw jacks, what I use particularly in automobiles to lift the chassis of the automobile whenever you want to replace the wheels or tires. So the first example is the screw jack, and particularly screw jack used to lift the weight. So you can see a normal person or the normal labor can lift the weight of the car from with respect to the point of where the wheel or tire is to be lifted, where the body has to be lifted up to replace the wheel or tire. So particularly screw jack, it contains or it has the power screw, and in this screw jack it is used to lift the weight. So you can see here we have the screw jacks or the power jacks. So basically they work, there are different kinds of screw jacks. Working principle is different. We have electrical screw jacks, or we have the hydraulic screw jacks, something like that. We have manual screw jacks, something like that. So here the basic application of the screw jack is that it uses the power screw. So this is the power screw and this is the nut here. So whenever the screw rod, so we call this a screw rod, whenever the screw rod, it is having threads, and whenever it is rotated, this particular nut, it moves up and down. So here the load will be applied and it can move up and down. And also in the lathe we use the lead screw, as I showed you in the previous slide. So we have the lead screw which is fixed at the two ends in the bearings, and it is rotated. So whenever the bearing is rotated, whenever the screw is rotated, so what happens on the screw, we will be fixing this carriage which holds the tool post or cutting tool. So whenever the screw rotates, this carriage will move linearly towards left or right, depending on the direction of rotation of the lead screw. So this actually lead screw, or what is called as the power screw or the screw rod, and on this this carriage acts as a nut. So nut is a carriage here. So whenever the screw rotates, the nut will be moving linearly. And we have tensile testing machine. So here the power screws are also used to apply the loads on the tensile specimen, which is fixed in the tensile testing machine here. So we have the screws here, screw rods here on both the sides, and whenever the screw rods rotate, so this overhead, this will move up and down, and simultaneously tensile load will be applied on the specimen when this overhead, crosshead or the overhead moves up and down. So this will be connected to the screw rods, power screws here on the left and right side. And similarly we have all of you know about this bench wise or the machine wise, and this is the screw rod inside. So this is the screw rod. Whenever you rotate this screw rod, we apply torque. This clamp, this holder will move away or inside. So we can fix the workpiece in between these two jaws, and these two jaws can be moved. So one jaw is fixed here, so other jaw can be moved left or right by rotating this lead screw, or what is called as the power screw. So similarly, many applications you can see here. This is the machine wise. Just now we saw about the bench wise. This is machine wise. Same thing, when you rotate this, when you apply a torque here, this this jaw will move linearly towards left or right, and we can hold or fix the workpiece or job here. Similarly, we have this clamp, C clamp. So this is called as C clamp because the shape is C, and it is similar to this bench vise. So we have the power screw here or the screw rod here, and it is fixed to the frame, and we can rotate this. We can apply a small amount of torque, and we can clamp the jobs or the workpiece in between these two jaws here. So similarly, we have the actuators. We have something called as linear actuators, which are used in robotics. So it is simply a motor will be there. When you connect the motor to the screw rod, whenever the motor is switched on, the screw rod rotates, and it can move the nut linearly up and down, or to the left or right. So similarly, we have these jacks here, power jacks, and all of you might have seen in the press, or we call this as simply as the fly press. So we have some amount of load here, and the torque will be applied, and you can see the lead screw here. So it is used to clamp the object in between these two, the lead screw and the base here. So this is also one of the example of fly press. You can see the lead screw here, and the job is held between the clamp here. So just by applying or rotating or applying the torque here, the screw rotates and it applies the force or the load on the workpiece to hold the job. So like this, screws or power screws are used for different applications in mechanical applications. So basically what you understand here is how these screws or the threads are used to hold the jobs, or to lift the weights. So basically they are used to hold the jobs, or to apply the load, or to raise or lower the load. That we'll see now. So basically, as I told you, the applications of power screws are basically in high efficiency requirements, where for example lead screws or the screws which are used in presses or fly presses. So here lead screws and fly presses, they are actually they are called as high efficiency elements, where the load applied or torque applied is used to apply the loads or to move the loads. And in some applications, what is happening here is the power screw is used to hold a particular amount of load or the force. So that kind of holding of the load is called a self-locking condition. This we'll analyze later. And for example, in screw jack, so it raises the load and holds the load at particular point there. So that there the requirement is low efficiency. Whereas in lead screws and fly presses, what happens is the load has to be applied. So we are not holding the load; it's applied on the surfaces. So that is called as high efficiency requirements. So these two you will understand later when you go in detail regarding self-locking and overhauling conditions. So basically, coming to the components or the parts of a power screw system. So power screw is not simply a threaded element. So it has three important parts called as. So one is the screw rod, or simply screw here, which has threads, and connecting to that there should be nut. So only a screw will not help us, or will not serve the purpose of transmitting the power, or to hold the load, or to apply the load. So whenever you use the screw rods, there has to be nuts. So nut is also inside. We have the threads inside the nuts here. So both screws and nuts, they have threads on them which mate together while operating. And obviously we require one frame, or the part which holds either a screw or nut in place. So you can see here, these are the frames. So this frame will hold the screw or the nuts in place. So basically the power screw system, we call this as system because it has three important elements or parts. So one is screw, nut, and other one is the frame. So power screws, they can while operating they can operate in three different ways. So one way is that the screw can rotate in the bearing and nut can move easily axially. So you can see here the screw is rotating, and this is a nut. It can move axially or linearly left or right whenever the screw is rotated clockwise or anti-clockwise. And second case is screw rotates and also moves axially while nut is kept fixed. So you can see here, this is the nut here. Nut and the frame is fixed, and this screw can rotate and it can move inside this fixed frame. And one more case is that nut rotates and screw moves in an axial direction. So here nut can rotate and also the screw moves in axial direction. So you can use all these three things, that is two things, screw rods and nuts. Either one you can rotate, and we can get the axial movements of either the screw or nut. So here you can see, in this case, this is also a screw jack which are used in automobiles. So once you rotate this screw, we have the links here, and this load will be lifted. So advantages of these screw jacks, or what is called as power screws, is that it can carry large amount of loads, and the design or the frame is compact in construction because only a few elements are used, for example screw, nuts, and frame. And it provides large mechanical advantage. That means a small load applied, for example if you apply 400 Newton, it can amplify or it can lift 15 kilonewton. So, and also the movement, the linear motion is precise and accurate because we are using the threads, and thread parameters are they are manufactured precisely, and it is noiseless, so it's one of the advantage. And you can get the self-locking condition in the power screws. So this self-locking we will study in detail while we analyze the power screws. And disadvantage is that the efficiency is less compared to any other mechanical system, and also the friction at the threads will be more, and there will be rapid wear and tear. That is the disadvantages. Coming to design, or what is called as selection of materials for power screws. So screw is subjected to torque, so you can see, and other axial compressive loads and bending moments. So usually the screws are made up of steel with the C30 or C40 grade steel, and we take the factor of safety of 3 to 5 because the power screws are designed for critical applications, and we should see that the failure or the chance of failure should be less. So factor of safety for this power screw will be taken in the range 3 to 5. And also the power screws, they have threads, and you know that threads, they are subjected to shear loading, and they can fail by shear. Therefore you'll be using nuts with sufficient length or height. So whenever there is shear, and also because of friction, wear is there, so there will be wear at the threads because the nuts and bolts, they move relatively. And the nuts are made up of softer materials because we can replace the nuts very easily, and their cheap manufacturing cost is less compared to the screw rods. And also you can use plastics for for making or for manufacturing nuts here, and because they have very good friction and wear properties. And plastic nuts are used for low load applications, whereas for high load applications we use bronze and copper alloys to make the nuts here. So you can see in this photo the bronze or the brass alloys are used as nuts here, whereas the screw rods, they are made up of steel. So coming to threads, you might have learnt in the previous sessions about the thread parameters, or the thread, what is called as thread parameters. So one important parameter of threads is that the pitch and the lead. So pitch is nothing but the distance between the two threads, or if you take a point on one thread, the distance between that point on one thread to the corresponding point on the next thread, that is called as pitch. So here p is the small p is taken as the pitch, and lead is one more term which is which you can say that whenever you rotate the nut or a screw by one revolution, that one distance traveled, or the distance traveled linearly by this particular thread or nut is called as the lead here. So here you can see in this first case, lead is equal to pitch. That means when you rotate this screw by one revolution, the linear distance traveled by nut or the thread is equal to pitch of this thread. So that's why it is called lead is taken as p. So in some applications, we make the lead as 2 times the pitch. So this is the pitch here. So in one rotation, the nut moves from here to here, that is L. So this L will be equal to 2 times the pitch here. So in one rotation of the nut, the linear movement of the nut is 2 times the pitch of the particular thread. So therefore lead is equal to 2p here. And there are some applications where the lead will be equal to 3 times of the pitch. That means in one rotation of the nut or a screw rod, the nut or the axial movement of the moment in the screw rod will be equal to 3 times the pitch. So you can see lead is 3 times the pitch, 1, 2, 3. So that is there. So based on the term lead and pitch, relationship between lead and pitch, you can call them as single threaded screws, or single start screws, double start screws, or triple thread screws, or triple start screws here. So in case of single start screws, pitch is equal to lead here. So this is the single start screw. So when L is equal to 2p, it is called as double start screw. When L is equal to 3 times the pitch, it is called as triple start. So like that, based on the relationship between L and P, we can have single start screws and multiple start screws. So the lead is basically, it is nothing but pitch multiplied by the number of starts. So in this case, number of start is 1, so L is equal to P. In this case, number of start is 2, so 2 times the pitch will give rise to the lead. So that is called as number of starts. So 2 is the number of start here. In case of 3, or what is called as 3 triple start screws, the number of start is 3 here. L is equal to 3p. So similarly, we have the same diagram explained here. Single thread screw or single start screw. We have a double start screw where L is equal to 2p. We have triple or 3 thread screw or triple start screw where L is equal to 3 times p. So here you can see in single start, in one rotation or two rotation, in one rotation of the screw, you can see there is 2 rotation. So 2 times the linear movement will be equal to 2 times the pitch. That is, if it rotates by one revolution, the distance traveled is equal to pitch of this thread. So we call this a single start. Similarly, you can see here in double start, in one rotation of the screw, the linear distance moved by the thread is equal to 2 times the pitch. So you can see the color, blue color, blue color. So in one rotation, it moves by 2 times the pitch. So it's called double start screw. So we have 4 start screw. So you can see here the color blue and color here. So in between that we have the parallel threads, 4 parallel threads. So in one rotation, the distance moved here is from here to here. Which is equal to 4 times the pitch here. So you can see that the distance traveled from here to here is equal to 4 times the pitch. Here in the animation it is rotating 2 times, but you take one rotation, it moves by 4 times here, equal to pitch. So based on the number of starts, we have single start threads and multiple start threads, or single start screw or multiple start screw. So in multi-start is nothing but 2 or more parallel threads will be there. So just now we saw that. So in single start, pitch is equal to lead, and depth of the thread depends on pitch. So these are the parameters of the single start and multiple start threads. So in multiple start threads, you should remember that L is equal to number of starts into pitch, whereas in single start, pitch is equal to lead, or lead is equal to pitch. So this is, again, you can see how the single start and double starts are manufactured here. Screws are manufactured. You can see the profile is different here. So based on that, you can see here. So here we have the single start and double start screw. So you can see in single start screw what is the profile, and double start screw how the profile is, and the helix angle how it varies. So that's it for this session. In the next session we'll look at some more concepts of the power screws. Thank you.